stop button instead. So, yeah, I think I had started recording, didn't I? We're recording, so be quiet. So given AD is parallel to ED, C is the midpoint, that says midpoint of ED, okay? You want to prove that C is the midpoint of AD, okay? So what I would do again, yeah, this means parallel. So I would first mark up what we know. AB is parallel to ED. So I'm going to mark up this with these little arrow things. Okay? I also know that C is the midpoint of ED. So what does that tell you if C is the midpoint of ED? What is it?
C. That's the midpoint of AD.
No, it doesn't. It doesn't tell you that it's the midpoint of AD. It just doesn't. Gary,
CB is going to C.
If C is the midpoint of EB, right? Right, then BC would have to be congruent to EC. Okay, even though it doesn't look like it. Okay? Now I'm trying to prove that C is the midpoint of AD. Okay? Yes, someone's in vertical angle. That's true. Okay? So I might want to mark up the vertical angle. What else would I want to mark up? Very good. So that these angles here, okay, are congruent to there. And now, because these make a Z, right, it's parallel lines, alternate interior angle. Therefore, how could this triangle here be congruent to that triangle there? Angle, side angle. Therefore, what would have to be true about AC and CD? They're congruent, and because they're congruent, then C is the midpoint. Okay, so that's kind of the reasoning they have to use. Guys, back here, there's a lot of steps, all right? It's not as simple as the last one. So the first thing that you do in your little box, and go through this because it's a little long. So in the little box, where's that tool I have? Okay? First thing, I'm going to have a little box over here, which says that AB is parallel to ED. And the reason for that is given. Okay? And the other given is that C is a midpoint. Midpoint of ED. Okay? So I'm going to put can I put a box around that?
Sure.
Well, let me do that. Let's see.
Draw a box.
Yeah, good enough. Okay? And that is also given. And now, from that, that allowed me to conclude that this angle is congruent to that angle. Do you understand that? Yeah. Okay? So from these being parallel, I can conclude that angle B, you could just call it angle B because there's nothing else that can be called up there. That angle B is congruent to angle, what? E. Why? Very good. Those are called alternate interior angles. And we had a conjecture back when that said if the lines are parallel, then the alternate interior angles are congruent. So you have to have a reason for each thing. What did C being the midpoint allow me to conclude? Nice. Good. Very good. Who said that? Devin?
I did.
Good. Okay. C being the midpoint allow me to conclude that BC is congruent to BC is congruent to EC, right? EC, and then I used 1/3 piece of information to show that my triangles are congruent. What's the third piece that Allison, or who came up with this back here? Not the alternate interiors, these two. Okay. I could have also used this because this and this also make alternate interior angles. I could have done that as well. Okay. Or let's use the vertical angles and then it would have been angle, side instead of angle, side, angle. But we're doing it this way. Oh, and the reason for this is definition of a midpoint. Definition of a midpoint, because a midpoint is a point that divides a segment into equal pieces. Okay? And then the third piece of information that I used was that I have a pair of vertical angles there. Okay? And so I'm going to call that, now I'm going to call that angle ACB is congruent to angle ACB is congruent to angle BCE. Angle BCE. And those are vertical angles. This is just kind of shorthand for vertical angles are congruent. Now I can take my three pieces of information, okay, put them together to reach the conclusion that what's got to be true? No, not yet, I can't. First I have to say that the triangles are congruent. So in the next step, I say that triangle AC, we'll call it ACB, triangle ACB, that says triangle ACB, my thing is kind of goofy here, is congruent to triangle ECD, or I like to call it BCE, to set up the correspondence correctly, BCE, and that was what? Angle side angle. Now I'm not even done yet. There's two more steps. The next step that I show, and I don't have to go directly up here anyway, I'm running out of room. Okay? So the next step I'm going to put right here is from that I can conclude that what? Good. That AC, that side AC is congruent to side BC, and that was CPCTC, and because of that, I can finally conclude that what I'm trying to prove, which is that C is the midpoint. C is midpoint of AD. Who can tell me why that is? Same as over here. The definition of a midpoint. Okay, because it has two congruent pieces, and so definition. I'm not too concerned if you have exactly the right words here, but as long as you can justify, because it's a midpoint or so on and so forth. So that's a little more complicated. First you use these two pieces of information to show that some angles and sides are congruent. You put those together so that triangles are congruent. Then these pieces are congruent because CPCC, and then definition of midpoint. So see how everything kind of leads towards the conclusion and you end up with where you're trying to get to. I'm not quite done. I'm not going to actually take you through the proof for the last one, but I at least want to show it to you, okay? I'm just going to draw the picture. So you could take a breather for a couple seconds while I draw this. Okay, quiet please. I'm not going to take you through this entire proof, but what I'd like you to do is look at it, okay, and see if you could think about it and figure out how you could show that angle 1 is congruent to angle 2. It's not like super straightforward. So think about it a little bit and then see if someone could come up and tell me, or you're being recorded, young man. I can't say your name live on there. But tell me what's true. What do I do? Go ahead. Young man in the blue shirt.
Okay. So, if angle B is congruent to angle G, and then line BC is congruent to DC, and then there's corresponding angles.
Corresponding angles.
Wait, what are they called?
These ones?
Yeah, right there.
Right.
Yep.
Yes.
And then lines BC and DC are congruent.
BC We already said that.
Oh yeah, so well that would that make the triangle congruent?
Angle side.
Oh yeah, one
Yeah, why?
angle side.
Angle, side angle. Then what? I'm not done yet.
That means that those small triangles are
So that would mean that this triangle is, we'll just call it triangle 1 and triangle 2. Then what? Then what, Julian? Very good. Perfect. Okay. See the way she went through that? Good. And we started out. So again, I'm not going to write out the entire thing, but the way this looks, first you mark it up. You know that angle B is congruent to angle D, right? And you're given that side BC is congruent to side DC. McConaughey added the vertical angle, so then we said that this little triangle here is congruent to that little triangle there by angle, side angle. Then the tricky part is saying, how do I get these two angles? Because you cannot prove that this triangle is congruent to this triangle, right? So what I do is I say that this side is congruent to this side, which makes this.
Wait, how is that the little triangle? How are they angle side? Oh wait, never mind. Wait, are they angle side angle?
Okay, so what I need to do is say that because these triangles are congruent, then these sides are congruent, which, as Julian said, makes this an isosceles triangle. And if this is an isosceles triangle, these base angles have to be congruent. So you should be able to write that up in a flowchart proof. So first you'd write your givens, then you write the vertical angles, then you write that these two triangles are congruent, then you'd write that these two are congruent by CPCTC, then you'd say that this is an isosceles triangle, then you would say that angle 1 therefore is congruent to angle 2. So it would be kind of a long proof, but you could do it. And you have a couple things like that in your homework. Okay? So your homework, which you're going to start on now, and if you